This conference will now be recorded.
So we have finished all this inheritance and types of inheritance, all that. Today we will start discussing polymorphism. Okay, so let's start this topic of polymorphism here. So when you talk about polymorphism, so we'll talk about object class again once I finish this polymorphism. I don't think this is a big topic about something called object class. This is a simple one. Yeah. So now the question is, what is polymorphism? See, this is there in in many languages, not just Python. We have it in C++, in Java, C Sharp, Scala, anywhere. The concept of the basic concept doesn't change. It is whatever the language it might be, the meaning and the usage, the purpose doesn't change. Only the way the here and there, a little bit of difference might be there. That's all. That's the idea about this one. So now the question is, what is polymorphism? It's simple. Poly means many, morphism means forms. And the point is, polymorphism means same method represented in different forms. Same function or method represented in many forms, and we call it as polymorphism. But actually, usually we have two types of polymorphism. One is compile time, another one is runtime. The default polymorphism happens anywhere is a compile time. But usually in Python, we don't have, you know, we don't have this. What is that? So compilation and execution happens hand in hand in Python. So that's why we don't have two phases of execution here. Suppose you go to C++, you go to Java, you go to C Sharp or Scala. All these languages has two phases of execution. This compilation, the other one is execution. As Python, we just execute it in single phase. I don't think we need to discuss this compilation, compile time polymer. Got it right? So usually I'll just give you a quick idea. Maybe even though we don't discuss this here, the meaning of compile time means there is something called method binding. Method binding means binding a caller to its appropriate method. We call it as method binding. And if this binding happens at the time of compiling a program itself, we call it as compile time polymer. And if it happens at the time of executing a program, we call it as a runtime polymer. Got it? But here, as we don't have two different environments in Python, so we don't need to concentrate on this compile. There is also one more important thing is usually in compile time polymorphism, we implement this with overloading, or even in almost all the methods. Whenever you have functions or methods, the method binding or the function binding happens at the time of compiling itself. Usually, this happens in traditional languages. But here you have interpreter. We don't have compiler. So it is the one which takes care of binding your method, your caller to the method. Okay. So we have only one here, the interpreter itself. We have just only interpreter alone here. Is the one which is responsible for implementing all these things. Okay, and we don't have two phases. So in that way, so we can exclude this. Why I just have given a quick idea is because if you go and look into some other books and if you just see the concept of polymorphism, they might describe this as like compile time and run time. And maybe if you just want to have a quick idea, what is this compile time polymorphism? It's nothing. Compile time or runtime, so it talks about the method binding. Method binding means it is not something which you don't know. You already know about that. It's that you declare a method and you have a caller. This caller getting mapped to the appropriate method is called binding. If it happens at compile time, it is compile time polymorphism. If it happens at runtime, it is runtime polymorphism. That's it. As we don't have two different phases here, also one more thing is Python is dynamically typed language. It is not statically typed language. It is not a static type. It means here you don't have explicit data types. Everything is implicit. So we don't implement overloading here. There is no necessity of overloading in Python. We don't declare no same method with the multiple parameters. We don't need it here because for one method we can pass different parameters. So that's why what is that? We focus more on function. What is that overriding, not overloading? And one more thing is if you see this Python doesn't support function overloading or operator overloading. This is not there here because why Python doesn't support this? Because reason is as Python is dynamically typed language. Usually, this comes like this. Overloading means if you see this example, this gives you a quick idea. You have same method with different parameters. When you have data types like this, then we can go for overloading a method. If you have the explicit data types and different data types, you can go for overloading a method. But as in Python, if you look at your Python program, suppose you define a method like this and you declare a comma b, you don't need even know the type until you pass the value there. Suppose you have something like this and you are just saying a plus b, assume that this is the method. Now you come to know about the data type only at the time of calling the method. Suppose I call m1 of 1 comma 2. Now we understand the type of these parameters only when you pass the parameters. Looking at the here this actual parameters which we are passing through caller. Looking at them, we decide okay, this variables will be holding integer type. Until that, we don't know what type of parameters these are. Second thing, this AB can accept any type of values. This AB accepts integer, float, double, long, accepts any type of data. It's not just okay, because these are dynamically typed. As we don't have a data type concept here, whatever the value you pass, then based on the data type of value variable is decided. So that's why there is no concept of overloading here because as we have dynamic data types here, the variables are dynamic. So to the same variables we can pass different types of values. To the same method, I can pass integer values. I can pass. You can see I can pass. What is that? Suppose I pass 10.0, 20 points. Does this method agrees or not? Does it accept this decimal values or not? Definitely it agrees in Python. Suppose I pass some Boolean values, true or false. Still, these are also accepted by these two parameters. Suppose I pass complex numbers, still this method accepts those complex numbers. Suppose I pass two strings, still this method accepts those two strings. Means what? To the same method, I can pass different parameters. That is the actual purpose of overloading. And guys, and we are getting fulfilled that here with the one method itself. If it is Java, if it is C sharp, if it is C++, the Scala, as they have explicit types, we need to go for overloading. But in Python, that situation or that necessity is not there because variables are dynamically. Hope this gives you a clarity to all of you, or anybody has any question on this. Right? Got some idea now? So finally, what is the conclusion here? The compile type polymorphism or overloading is not supported in Python. The reason is simple. As we have dynamically typed language, when you look at the example just we have discussed, a method in Python accepts any type of value. Usually the purpose of overloading is for the same method, we should be able to pass different types of parameters. As in other languages, we have different data types. We define methods like this with same method name but with different parameters. So for one time we declare with integer, another time we declare with float, another time we declare with double like this. So this gives the developer an opportunity to pass to the same method with different values. As it is different in the other languages, the data types are there. So that's why what is that? So to give developer or to provide developer to an opportunity to pass different values to the same method, overloading is implemented like this with same method with the different parameters as they have different data types. But for us, we don't need that because Python is dynamically typed. Hope this is clear, right? So now, what else? This is a simple example I tried to show to the learners there. If you see, this is an overloaded program. If I try to declare the same, this is overloading. You can see F1 without parameter, F1 with one parameter, F1 with two parameters. Suppose if you try to run this code, you copy this and run it. What happens? Do you think this will work? Do we get? Do we? Are we going to compile and run this? This compilation will be successful. We'll see this. What happens if you try to implement a similar concept of overloading, which we do in other languages, the traditional languages in the Python. Usually this is not there. This is not required. Okay, but still, out of curiosity and out of just to get some quick understanding, if you try overloading like this in Python, what happens? This doesn't make sense actually, but still, if you want to check it out, let us just quickly run it and see this. For I am using what now? Let me use PyCharm. Give me a minute. Let me open that PyCharm. Now I have this file here. I'm just trying to copy and paste the code. Now you can see here how many methods are there. I declared 3 different methods. And now what I'm doing now, I'm trying to call F1 to F, right, the third method. Okay. Let us try to run this program. This is overloaded. Run this. And you can see here what's happening here now. We are getting this last function is getting executed. Similarly, if you look at this, what is that? The second one. And one more thing you need to observe here. Here, how many functions do you think are going to be created? Is it one function or 3 functions? If I declare like this, F1 without parameter, F1 with one parameter, F1 with the 2 parameters. Could you tell me how many functions do you have? Do I have here? Do you have 1 or 3 here? Any idea? Any answer? Okay. Are you sure that you have three functions here? Okay, I'll do one thing now. I'll do one thing. Suppose you know, right, how to how to get the address of a function, right? You have an idea, right? How to get the address of function, something like print of. If I print F1, okay? If I print F1, let's run this now. This is the address of F1. Got it, right? It's okay. Do you get this point, right? This is the address of which function? F1. Now, even in the second case, even in the third case, this do you think this is going to change? Now, what I'm doing now, suppose, or what can we do now? ID of, right? You can also get ID like this. Let me try like this, whether this will work. So now, if you see one more thing here, if I am calling a default function, if you see one more observation, good observation. Right? I have three functions. Now I am trying to call which one? You see here running. You got an error here. Can you see this now? It is showing error. F1, which is default function, which I am calling here, it is saying missing two required positional parameters. It means what? When I try to overload, what's happening in Python is it is considering the latest method which you have implemented. The remaining two, no, they don't exist. They don't exist physically. It might be on. You can see it on the screen. Okay, you can see it in the file, but in memory, the last one is created, and Python will only look for the last method, not for the remaining two. As per Python, these two don't exist, F1 and F2, because if you see when I try to call F1 here, what it is saying, it is looking for the method with two parameters. It is not looking for default method, but that method is there in the file, isn't it or not? Function is there, right? Similarly, that is a clear proof. What is that? But if you do the same in other languages, suppose you go to Scala and you try this. Suppose you go to Java and you try this. This will succeed. You can call all the three methods. I can call F1 without parameter and F1 with one parameter and F1 with the three parameters. This will work in other languages. But here it won't work because Python don't see when you declare multiple methods with same name, it doesn't see all the methods. It will just only consider the latest construct. Got it, right? So this is idea about what is that, folks. This is what happens with Python. What is the conclusion? Do you think it is supporting overloading here? Do you think it is it is do you think we can work with all the methods which I declared here? If that is the case, now you have seen the output. Now you should conclude yourself what is that, whether it is supported here with the Python. What is your answer? Does Python support overloading here? Yes or no, sir? Does it support overloading? Yes or no, sir? Can somebody answer this question? Is it supporting method overloading? You can see here physically, right? We have practically observed the things, and even the documentation doesn't talk about overloading anywhere. You can check it after the session also. You can cross check. Okay, that's the idea about that one. Now runtime polymorphism, and here in Python we have just only one polymorphism, that is overriding runtime polymorphism. We don't have compile time here because we don't have overloading. Okay, there is nothing like overloading here. Right? It's applicable for polymorphism. I'm talking about polymorphism. What is overriding then? This is a simple concept. First thing, if you want to implement, the point is we should have inheritance. Inheritance must be there. Two classes must exist, a parent class and a child class. That is very important. So, as discussed with you people, if function binding or method binding, because as we are talking about the functions inside class, you can also call it as methods. If method binding happens at the time of executing a program, we call it as runtime polymorphism. And we had discussed very clearly. And we implement runtime polymorphism using overriding, method overriding, or function overriding. What is function overriding? It's simple. It's not something too difficult. I have two methods. Okay. I have a class like this. I'll just show you with a small quick example. This is not something too difficult to understand. Suppose you have a class something here. Inside that there is one method M1. Okay. You can take instance methods. Usually we override instance methods. And there is something inside this printf. What is that? A. Okay. Now, excuse me, sir. I take one more subclass and I inherit this B from A. Okay, sir. Now, what are the method that is there in A class? I am overriding that in B as per my requirement. So I am not inheriting it as it is. We are not inheriting it as is, but what I am doing now, I am overriding it. I am overriding it as per my requirement. Suppose, just for quick understanding, okay, this is not something really difficult thing. Okay, here I am just showing it as B here. If I am showing the method of A in the method in A class as printing A, I am showing the method in B, showing it as B. What did I do now? If you look at it, I did do something really strange here. I have a method in parent. I have implemented the same method in child class with same signature, but different implementation. If you look at the method body, if you look at the statements in the method, you see the statements are changed here. Of course, here I am just only changing the prints, but usually in a real use case, the business logic of parent class method is overridden in the child class method. Of course, the signature will be same. The business logic will be modified because when you extend B, might be by the time you extend this A, this method logic, business logic is not sufficient or is not useful for the situation while implementing this method. So what we do then, if it is not useful or it is not necessary, then what do we do? But we need the same method signature because we cannot keep changing the method signatures constantly. We have to, that is one of the good programming practice we have to follow. And here, to keep that method signatures limited, so this is one of the best use case, overriding. Okay, so what is that? Here if you look at this, the same signature I am going to implement it in the child, but what is that? But I am going to implement it with the different logic, business logic. That is what we call overriding. Overriding means defining a method of parent in a child class with same signature but different implementation. That's what we call it as a override. Got it right? That's all, sir. That is not something difficult at all. Now, if you look at it, okay, what is overriding? Defining a function of superclass in a subclass with same signature but with different implementation. And you know, sir, as per just these are our terminologies. The method in the parent class is called our superclass is called overridden method. The method in the child is called overriding method. If you want to remember this terminologies, remember it. Or if you want to ignore, please ignore. This is not something to be worried here. Okay. Understanding the concept is important. Like, technicalities, when you are just going through that, you can remember it. So when you say what is a method signature, Usually, signature of method means that function name and parameters. That is what signature is. When I say signature or prototype, you don't need to get confused, sir. Simply in a simple way, just the definition of method, you can treat it as a signature. Got it, right? So that's it, sir. That's the idea about what is that, sir? Idea about this one, overwriting. Concept is so simple. What you do, sir? You just simply create object here. What is that, sir? You create an object for which class, sir? B class, B equal to B. And then you can say B dot M1. Got it, sir? So this is simple. And similarly, if you want, you can create an object for A also. A. Usually we don't create object for superparent classes. It is better to create object for child classes, because the child class has access to properties of child as well as parent. So always it is recommended to create object for a child class or a subclass. Okay. So anyhow, if you wish to cross check it, you can call it. You get my point, sir? Do you get it? Now, what is the output of this one? This M1? Here, this is A class M1 is called directly here. The overridden M1 is called here on B object. Got it, right? This is simple analysis about what is that, sir? Overriding, you can see here. And I try to add one more scenario here. If you look at it, the example out of my what is that? This is scalar. I'm sorry. Out of my experience with Java and Scala, I try to have this scenario. What is that? A parent reference. So reference is parent. But what is that? Method is a overridden method. So the point is, what is that? Just to understand dynamic method dispatch. Now, when I say b dot a, of course, this is a bit not necessary. I tried to test it some time back, but here you can just skip it, sir. You can skip it. Anyhow, I created an explicit object in B class. You can see here. This is a as a relation, what we call. If you try to create object one class in another class like this, we call it as what, sir? It's called as a relation. Of course, usually we create it as instance. Here it is made it as a static variable or a class variable, but for just a quick understanding. Okay. So I'm doing something here that is not necessary now. Okay? You can skip it. This is simple idea about overriding. Okay. Please test it, sir. Test this example. Take 2 minutes and test the example, sir. So hope Ayappa, how are you and how is Corona in US?
Still same, sir. Keep on growing.
Okay, that's fine. Take a minute and test it, sir. Then we'll switch to the next topic. Yeah, you don't call, yes. If you want to call parent method on child object, even here also we use this concept of super that is there. 1 minute, Shiva. I will show you after this, okay? And somebody is asking me a question: where do you use this in real time? See, one thing I would like to tell to you people is, all of you folks. So this is useful when you are working with more on web development, web applications. See, where do people use more of object oriented programming? If you go to web development like Django, Flask, if you create some websites, there we use a lot of object oriented programming, because as we are more of data people, I see most of we are Python. We learn it to get into this data analytics, not like to get it to become a web developer. Most of the people, what I am saying, who are trying to learn this Python course here. Now, for us, your functional Python is sufficient for us. Even this object oriented is good to learn, because sometimes we use all the built-in classes and we understand like how to create objects, how to call methods to get a detailed analysis. But actually, where this polymorphism or all these object-oriented concepts are extensively applied, or it is used, in large scale, means generally when you create some frameworks. Suppose you are creating a framework, or if you are creating some API, then in such case we definitely use all this. Suppose you go to the web development. Even in web development, we pass a lot of objects. We see this inheritance is implemented in the project. So in such cases, even then, this what is that? Even in that situation, we prefer this polymorphism or any other object-oriented concepts. Okay, but as a data people, I don't think we use this concept very frequently. I don't think so, because I know, right? I'm using my data analysis. We are doing some automation for our big data projects. We depend more on core Python than this object oriented thing. Okay, probably I don't see any one of us writing a class program to do the automation. I don't mean that we don't completely avoid. We might take some built-in classes and we create objects and we try to call methods. That is a different way. Got it, right? But exact opportunity, where do we get it? We get it in when you design some frameworks and APIs. That is one scenario. Second case is if you are working in a application like UI applications, user interface or web developer, web development applications. Then you might get an opportunity. Got it, right? Anyhow, I didn't completely explain this. And also somebody is asking, from a subclass method, how can I call from a subclass object? Through subclass object, how can I call a superclass method? There is actually a super keyword. Somewhere I had explained that as well. We can use some super keyword here. Using that super keyword, we can have access. Maybe let me just check it, because somebody is asking me a question. Here, see. The super method is there, right? This is the one we use in Python to call a superclass method from a subclass. Got it, right? So Shiva, this is for you. I think Ayappa got his answer, and this is for you. We use this generally, when you have, suppose like this. If I want to call a superclass method from subclass, suppose what I can do now is I want to call even the method of superclass. Then I can do like this. I can simply say super dot m1 this. Now when I call m1, what happens now? When I call m1 will also call method of parent. Now if you run this code, you see here, you can see here what's happening. The first output is coming from the A class. The second output is coming from method of B class. Now what B class method will do? First it will call M1. That M1 will call super class method M1, that is A class M1. Then it will print A, again come back and print the value of M1 method of B class. Then we get B here. This is what happens. This is how you can call what, Shiva? A parent method in a child class like this, on child class object. Got it, right? If methods are same, you can't call directly. See, even in any other language, when you have same method overridden in the subclass, you don't have any other direct, any other way to call this M1 again on A class. If at all, if you want to call A class method through B class object, the way is what our way is. This is the way for us. How do we do that? We do with the super method. You get this, Mr. Shiva? Are you there, man? Shiva? Yeah. So this is anyhow. We will discuss that when we go to the topic. This is simple to understand even now, because what's there in that? The name itself says super. Means what? Super is a method which is used to call members of parent from a child. Usually we have used that super when the members of superclass and subclass are same. To avoid that ambiguity between method members of our variables of superclass and subclass, in subclass we call parent members through super method to avoid that confusion. That's all, nothing more than that. When the same properties of A are declared in B, not used in B, are declared in B. Got it, right? That is the difference. So anyhow, we will come to that. That is there here. I have included that scenario as well. So we don't need to worry too much about it. But still, I didn't completely given that understanding of this overriding. Overriding generally it's something called a runtime polymorphism. Usually that happens at the time of executing program. Means what? Let us understand this in a more deeper way, in a more deeper approach. Okay, by taking few more examples. Now, if you see here, actually, when you talk about overriding, this is one thing you need to understand this point. Okay, what is that? Is you have a method in parent. Let's understand this use case. You have a method in child. You have a bear here. Bear will make some sound. We have a dog here. Dog will make some sound. Now you have a make sound here. This is actually the perfect example to understand runtime polymorphism or overriding. Okay, view this scenario. If it is in other languages, it's easy to explain because they are static type, so that it's easy to show that. But in Python, the problem is as everything is dynamically typed, so it is a little different, or the way we understand or try to use that approach is a little different here. Okay, so we will just see here. Now, if you look at these examples, let's have a perfect idea about how overriding works and what is runtime polymorphism or what is dynamic binding. As I had discussed, now the definition says something here. What is the definition? If binding happens at the time of executing a program, we call it as runtime polymorphism. Means when you run the program, then only you understand the binding thing. How do we do that binding here? In case of object-oriented programming, how this dynamic binding happens? We are just doing a kind of simulation to get some idea about dynamic binding. Dynamic binding is nothing. Binding a method call to a method at the time of executing the program. That is called dynamic binding. Now you see here, I have two classes. This code is so simple for everyone because you have done enough programs on classes and objects, as well as functional programming, as well as logic building. Now I have a method sound in bear, and we have overridden it in child here. Of course, instead of object, you can remove this. It's not necessary to have object. You can also, what you can do, you can just simply say inherit it from where, okay, and you can override it. Now I have a method in child here. Now I take a method, the same method, 1 minute, sorry. Now I have overridden this sound in the child class dog here. Assume that usually dog won't be a child of bear, but we assume that dog is a child of bear here. Okay, now I'm overriding this method as per the dog's nature. So what did I do? Same sound method, but the implementation is different. Now I took one function which is not part of class, but a common function for both the classes. Now I'm taking a parameter as animal type here. On that reference, I'm trying to call this method sound here. Means what? We had seen, I told you number of times. If it is a method to a method, we can pass any value types and we can pass any object type. We have seen that in the beginning of classes and objects. I asked you to pass collections to methods of a class and try to do some processing in that, if you remember. Okay. Even we can pass objects, we can pass collections to these methods as well. Here to the methods of a class, we can do all that. Okay, that is fine. Now the question is, this animal type is an object. Now on this I am trying to call this sound method. Now at this point, just understand the program. You can just cross check it. At this point, no, right? When I say sound in this method, when I call sound, now you tell me, you answer this question. Which sound method is called? The sound method of bear class or the sound method of dog class? Which sound is called? Can anybody decide this just by looking at the method and by looking at this color? Can anybody decide this? Tell me. Yes, sir. Yes, sir. No, sir. Okay. No, right? Right. Perfect. That's what. Suppose if you look at this, no, not this one. This is also overrated. If you look at this program, we know we had already analyzed this, but still, when you look at this color and when you look at this method, you can decide which color is going to map to which method. This is decided. We can easily decide this, right? You can decide this here directly without any analysis. Correct? So, but here in this example, if you look at this example, I cannot decide which sound method is called until you execute the code, until you run it. Got it, right? Now, when this execution happens, here when I call this method, then only I come to know that what is coming from the caller and what sound method has to be called. Now you see here, I created two objects, one for bear, one for dog. Now, at the time of calling method, for the first time, I'm passing bear object, and for the second time, I'm passing the dog object. By looking at these colors, now you can decide which sound method is called here. By looking at this object, you decide which sound method is called here. Correct? Now, until you execute this and you call this method and you pass this parameters, this object, you pass this object, you cannot decide which sound is called. Means what? Runtime polymorphism happens based on object. Overriding, the method resolution of overriding happens based on object. By looking at object, you conclude which method has to be called, either the method of a parent or either the method of a child here. You got this? So this is simple analysis. This is a simple use case to understand what is that overriding. Means what is that? At the time of execution, the binding of a method call means method happens to a method based on object here. Based on object, your interpreter decides which method has to be called, either the method of bear or either the method of dog. This is actually the overriding concept or runtime polymorphism. Do you get this point? Do you understand this, sir? So we will test it, sir. Let's quickly test it. Of course, Dog being a child of bear doesn't make sense. That's for sure. But for testing purpose, where this animal type object is created. Harsha, animal type object is declared with the method, the function. It is declared as a parameter to the function. That is declared here. Got it right? That's a local variable to the method, to the function. Got it? What you are expecting, I really don't understand. This is already a local parameter. In Python, for readability sake, I declare it as animal type. Otherwise, you can put it as XYZ also. And any variable accepts any type of data. It accepts value types, it accepts objects, it accepts collection, it accepts me also, Manohar also. You got my pointer? Because they are dynamically typed, it takes any objects, even your integers or decimals, even they are also objects in Python. Okay. So let's run this program quickly and conclude this topic so that we are done with this one. We are done with the overriding. If any use cases were there, we will discuss and close this scenario. One thing you have to keep in mind is in this overriding, the method resolution or method binding happens based on object. By looking at object, your interpreter will decide. Even the same concept, if you go to other languages, object plays a very important role in method binding when you are going for override. Okay, right. Let's just run this one. So I'm not getting anything here. Somehow this prints came down. Fine. Now let's test it once. Run it. And moreover, this print. Okay, let me run and see it whether it works or not. Yeah, because this is Python 3x, right? We use this kind of prints in Python 2x. So I have to put parentheses. Okay, now this will work. Got it right, sir? We have tested it. We analyzed what is this overriding. Concept is so simple. Defining method of parent and child with same signature but with different implementation. Usually in a real time, it's not the print we change, it's the business logic. Generally, when do we go for this overriding is if you are not satisfied with the implementation of a method of parent, if the implementation is not suitable for the current requirement. Suppose you have implemented this code like 2 years back. Now all of a sudden the requirement changed, but you cannot have a different method. The objects should belong to some animal type. So in that case, what is that? We keep that parent as is, we don't change it, and we use the same signature of parent method, but we implement it in a different way as per the current situation. So in that way, overriding is very useful to make sure that what is that? You are to implement a different business logic with the same signature of a parent class method. Got it right? So this is an idea here. One more purpose of overriding is when do we go for overriding? If you ask me a question, if you are not satisfied with the implementation of method in parent, then we override it in child as per the current situation, current requirement. Otherwise, if this itself is satisfying the requirement, you don't need to override that method in child. Unless and until a new requirement came and you have to modify it, then only we do that. That is also one more important thing you need to understand. Okay, you can test this, sir. This is not difficult thing. Please test this code, this concept of overriding. Okay, then we'll see what is the next topic. Hope this is done right, sir. So this is tested. Is it done, sir, all of? Okay, fine. Next one. The other topic is
Bro,
abstract. Yes, yes, sir. Madhu, Chapad, please.
I think yesterday you told me that when we are discussing in Scala, overloading we can implement with changing of data types as well as changing in number of parameters.
Correct.
I agree. As you said, it is a dynamically typed language. It doesn't support with the changing of data types. But
Okay.
changing of parameters also will not support.
No, that won't support. We have seen that example here. See here. You just look at this example. It will only take when you have same method signature, it will consider it as one object. It doesn't, even functions are treated as objects here in Python. You know that, right? Madhu?
Yeah, yeah, yeah.
See this, suppose. Can you see this, right? So here, this is overloading. Will you agree as per Scala? We overload in Scala like this, correct?
Yeah.
We have discussed this actually. See, now you try to call F1 now. Okay, you try to call at least F1 at the end like this. And then F1 of another with one parameter. Now if you run this, see this now. You got an error here. Can you see here now? What is that error? F1 missing two required positional parameters. What does this mean? Means it is taking the latest version of F1, not the previous version. And here
Oh, mhm.
you got the point.
Yeah, I got.
This won't work. The kind of scalar kind of overloading doesn't work in Python because Python don't support overloading itself. First thing,
Okay.
got it right?
Yeah.
So that's it. Next one, abstract classes. Another topic in another important topic of object-oriented programming. What is an abstract class? Here we don't have any abstract keyword. Suppose if you go to other languages, you go to C++, you go to Java, C#, Scala. The concept of abstract classes is implemented with abstract keyword. Okay, but here we don't have that. Even in abstract classes, the concept of overriding will be there. Okay. Now the point is, we have discussed this inheritance. Now we have discussed polymorphism, overriding. We have seen some examples. I hope that gives you some perfect idea. We have seen what is dynamic binding and how binding happens based on object. We have seen all this in polymorphism. We have seen all that in overriding, right? Now, even in abstract classes, overriding plays a very important. So, what is an abstract class? First thing. Point one. In other languages, we use abstract keyword, but in Python, we don't have any abstract keyword to declare abstract class. It is similar. It is a actual class, normal class only. It is not something too different. Okay. It looks like a normal class, but little difference is there here between normal class and abstract class. Usually in abstract class, we declare abstract methods and non-abstract methods, both methods. But in a normal class, we declare only normal methods or concrete methods, method with the body. Okay, I will give clarity here. When you look at this definition, what is that? A class with abstract function or functions is known as an abstract. Now the question is, what is an abstract function? A function without implementation, a function without body, or it doesn't have any business logic. Such methods we call it as abstract. The concept is same in any language. The way we implement might change here and there little, but concept of what is that object orientedness doesn't change. Okay, few differences might be there. The way the objects were created in memory, or the memory management might be little different to Python compared to Java. Okay, but the syntaxes might be little different. Concept is same, sir. Okay, now the point is, what is an abstract class? A class with abstract methods. What is an abstract method or a function? A method without any implementation, a method without body. You see here, if you look at this example, document example, the first one is non-abstract. And when you say non-abstract, it means concrete method. What is concrete? Concrete means a method with body with implementation. Technical words. These are all the technical words. When you say concrete method, what is it? A method with the body, or body in sense blocks. A method block exists for a method, or method with what? Body or implementation. And we call this as what, sir? Is known as what is that, gentlemen? Concrete or normal method otherwise. Okay, abstract method means a method without implementation, or a function or method. Both are same, sir. You don't need to get confused. Without implementation. Now you look at this example. In this class, the first one is a concrete method. This constructor. You know this is a constructor, right? All of you know this. The second one, when you look at this show method, you can see here, sir. I didn't implement any business logic here. Yeah, at least a print. There is nothing inside this. I just only added one exception here saying that raise not implemented error. Suppose if you are inheriting this document, if the child class is not overriding this. Now here, definitely when you have abstract methods, a method without body, a method without implementation, what is that we should do? Here, such abstract methods, we should override them in a subclass. We should inherit this class to some child class, and we should override this abstract methods. Or we can reframe it in other way as well. Whichever the class inherits an abstract class, whichever the class extends this abstract class, inherits this abstract class, that subclass must override all the abstract methods of abstract class. Otherwise, it leads to error. It leads to syntax errors. Got it right? So another important point is this is abstract method, but I hope this is clear for all of you without any body. I put this because under this, this is just an exception. Forcing the child class to override this method. By now, just now we finished discussing overriding. For the first 1 hour, we had discussed overriding. And what is overriding? Declaring method of parent in a child with same signature but different implementation. Usually we can override concrete methods and abstract methods. And both are instance methods, nothing to worry. You can see here, this is an instance here. Even the examples which we have seen, even they are instance methods. You can see this is an instance method. Overriding is applicable for methods which are part of object, means instance methods. Now the point is we can override concrete methods, we can override abstract methods. Concrete method overriding is simple. Already there is some implementation to that method in a parent. We override it with a new implementation in the subclass. Abstract method means it is just a signature. It's a prototype. Now what do? We override with that in the subclass. Means what? The same method, the same signature, we provide implementation. You got this point? So in the parent, it doesn't have implementation. Now in the child, I provide implementation. I implement the signature. I use the signature and implement my logic, my business logic as per my requirement. And we have a lot of, sometimes we might have a number of abstract classes in a in your project. Got it right? Usually, why we go for abstract classes is okay. Suppose if the implementation is common for all the subclasses, you have a number of subclasses here, and this method implementation is common for all the subclasses. We provide implementations to such methods. You know, right? The concept of inheritance. When you declare something in a parent, what do you mean by that? Parent has the common implementation. Whatever is common for all the subclasses, we declare them in the parent. Whichever changes from subclass to subclass, we declare them in the subclasses. Now, to increase the standard of coding, instead of every parent, suppose I need show method, that show in all the subclasses I need show, but the implementation might be different. Instead of suppose I want to show something, but every subclass, suppose if document have many subclasses like this, a Word document or PDF document or some other document, whatever it is, these are the subclasses for document. If every subclass is implementing one show method, like here PDF uses display, Word uses some show, and some other subclass might use get data, something like that, or get some info, something like that. So what's going to happen is it is going to increase number of method signatures, and down the line sometime later what happens is when the developer is trying to get the methods, he might the number of this is going to increase the method pool. When the number of methods keep increasing, automatically the project size gets increased, right? Just think about it. Now, to keep all that intact, instead of increasing that confusion to the developer and also increasing that number of method pool, we can simplify that with making these methods, because only thing is we need to display something, but the displaying should be in a different way for each of these subclasses. So in such cases, instead of going for different method in different subclasses, because the purpose of such methods is same, but a bit of implementation might change. In such cases, what is it? We declare such methods as abstract methods in the parent. And why should we declare it as abstract here? We are forcing developer to use the same signature in all the subclasses, so that what happens? We don't have different methods for different subclasses. One thing, for the same a similar kind of requirements. Second thing, it is not going to increase number of method pool, because when you have more methods, automatically developer has to spend more time on the API. When you have less methods, you need to spend less methods. The actual thing I am talking here. Got it right? So in that way, abstract classes are phenomenal for us. Got it right? So I declare a method signature here just without body, and I force the developer to use the same signature in all the subclasses. You can see here. In this PDF, I am extending document to PDF. Now I know all of you are good with inheritance, overriding, also what is that other class topics like static and class methods. Now if you see, this is an abstract class, sir. How can I say this is abstract class? Because I have declared this as what? I have declared an abstract method in this class. So we can call this as abstract class. What is an abstract class? We have already discussed clearly. What is it? A class with abstract functions. And what is abstract method? A method without implementation, just only signature, method signature. And now if you see here, we have defined a document class with an abstract method. Another important rule is we should override, or whichever the subclass inherits this abstract class must override all the abstract methods of a parent. Otherwise, it leads to error, syntax error. Another important rule is a subclass which inherits an abstract, which one? An abstract superclass must override all the abstract methods of a superclass. Very important. We'll check it. We'll check one by one. Got it right? This concept is same. The concept of abstractness is same. Also, one more important point. So here you are hiding the implementation. You know, right? You know the principles of abstraction. So when you talk about object-oriented programming principles, we see object, class, encapsulation, abstraction, inheritance, polymorphism. We have discussed. So we have a straightforward discussion for that. Object and class is a straightforward discussion, but still I didn't discuss encapsulation and abstraction. Remaining all other principles are discussed with the use cases. We are clear with that. Now this is time to understand the concept of abstraction. There is a lot of confusion to many people. Abstraction means you are just only providing the signature for the user. You don't provide the implementation. Got it right? You give what is necessary and you hide remaining things. And that is what abstraction is. Suppose you are in the class here. You know, if I ask your name, it's fine, it's good. If I ask where do you work, it is also fine. Okay, if I ask what is that, which domain you work, that is fine. The next question, how much salary you get, means that is actually that is not necessary question. Or if I ask you how many, are you married or unmarried, I don't need to know that. Okay, because to learn Python, you don't need to know all that. Got it right? And if I ask you how many parents were there, how many kids were there, means that is another unnecessary question. Suppose if I ask how much property you have, means that is one more unnecessary question. Then after a certain time you get irritated and you ask, why are you asking all this? If I should attend Python session, you should know my name. That is fine, because you need to call sometimes, or at least you should know which technology I am. That is fine. Why do you need all this? That is abstraction. Means what? Know what is necessary. You don't need to know what is unnecessary. That is abstraction. Got it right? So what is abstraction? Providing the essential information and hiding background details. That's what abstraction, and that we do with abstract classes and abstract methods. You just expose method signatures, sir, and you don't expose method implementation, and that is taken care by the subclass methods. In the parent, you just only expose the method signatures to the outside world. You got it right. And this is nothing but we call it as abstraction. Got clarity here? And so these are all concepts, the object oriented concepts. Just get some idea. Okay, now what do you do right now? This is our document. Okay, let's test it, sir. We inherited two subclasses, PDF and Word. You can see here I had just overridden this show method here in the subclass. Okay, and that show is giving something here. It's just saying returning show PDF contents. And in the second case, Word is also overriding show method. It is showing show Word contents. Now here, if you see in this collection, this is a collection here. It has three different collections. These objects, two PDF objects and one Word object. Now what I am doing now, and that is assigned to this variable documents. Now once I create this hierarchy, this document and PDF and Word hierarchy, where I have overridden the show method, and show is an abstract method here, so that we treat this class as abstract class, this document as abstract class. As per the Python people, if you have abstract method in class, that becomes abstract class. Now what I am doing now, I am creating three objects, with a collection here. Now what I am doing now, after that I am iterating this. You can see now these documents I am iterating in for loop. In that for loop, if you see here, what I am doing now, one is I am trying to get the, you can see here the constructor. The constructor is taking name as parameter, and we are setting name to that this instance variable. Now when you create object, the same constructor is invoked on PDF. Even we can invoke the same constructor on subclasses as well. Suppose if I create object here with parameter, then this will invoke this parameterized constructor with one parameter. Now I am passing string to that. That string is assigned to this instance variable. Got it right? Even second time the same constructor is called and document2 is passed and name is set to document2. Third time we are passing Word, then Word is going to be passed as a, this object is there. and this string is passed as parameter to this name, okay, to this parameter, to this constructor, and then that is initialized to the instance variable name. What I'm doing here is we are just trying to call what is that one, the name as well as the show method. Now, how do you know that which show is called, which name is called? For the first time, based on object again. If the object is PDF, the name attribute from PDF is called and show method from PDF is called, because it has overridden show, and by default what is that, name is available for PDF as well as Word because it is inherited to subclasses. The properties of parent are automatically available to child, sir. Got it right? So the same name can be used by this subclasses, okay, but with different values. You can pass different values and set that name to whatever value you want here. Okay? I think this is clear, right? Maybe if you don't want this looping all that, you can just make it simple like what we have done in the previous case. What is it? Just create a simple method, a function, like like a document type as the parameter, and you just create simply two objects and just pass it. Just to understand the concept of abstract class, we are trying to do this. As we already discussed all these concepts, every topic in this program is discussed. So I took this example because we know collections, we know how to pass objects, collections, and we know when you just try to execute this object, automatically constructor is called. When this object is created, constructor is called, this parameter is passed to constructor, and it is set to this instance variable name. All these things were discussed in this, whatever the example you are seeing here in this document, everything is clearly explained to you in the previous sessions. Got it? Right? And if you want me to simplify it, so we don't need this. The inheritance is hierarchy is very clear for us, and this abstract method is clear, abstract class is clear. Here, somewhat this taking a collection and creating multiple objects here and iterating it on top of that, calling name and calling this show is something little, it is going little deeper, means we can simplify it. Shall I continue with the same thing, or shall I just no, make it simple? What should I do, sir? Are you fine now? Is this clear to all of you? Okay. If anybody wants to simplify this, just tell me, just ping me. I can just simplify it. Instead of I can remove loop there, and I can also no need of cancel, this collection. Okay, this is itself. Just no, this version is this prints are from 2.x. So what we do is let me make a quick change here, sir. This will work. No, nothing to worry about. We are just threatening, right? We are not printing that. Now you see, sir. Let's just test this code now. Right? We have three objects in this collection. When you start iterating, first you will get PDF object with document one, and when you say document.name, you get document one, and document.show means you get show PDF contents. And second time, when you iterate it one more time, it will try to iterate this object again, and at that time, what happens? It will try to call which one, sir? It will try to extract name from the second document, then document 2 gets printed. Then when you say document.show, then again same PDF content. It will this show method is called, and it will this string is displayed. Of course, calling constructor happens at the time of creating object itself. When you create object, automatically constructor is called, and to that objects, PDF object and Word object, to these objects, the name is added to that objects exclusively. Okay, for each object that name exists for this first object, second object, and third object. Got it right? When third time when you iterate again, already document has that object has a word has that name inside that, and you are trying to call it. Also, show is also part of that. Then that is called. When you say document.show on Word object, then you get show Word contents. And when you say here document.name, this value is printed. Now let's run this. run this. You can see here now. Perfect, right? Document 1 show PDF contents. Document 2 show PDF content because both are PDF objects. Document 3 Word content. So because it's a Word object. Got it right? So this is idea about what is that abstract classes are. Is it clear now? You do one thing, sir. First you test it, then we will check like few pros and cons. What is that? Let us not try to override it and see what happens. If I don't override, does anything happen to the subclasses? Do you get any error or not? We will see all this. We'll cross check all that. But before that, you first finish testing this code set. Then we will get to that point. Okay. Before going to do that cross check, we'll quick workaround on these things. Please finish this testing. Yes, and there raise is a keyword. Correct. Is it tested case completed? Okay, fine. Okay, we'll just do a quick workaround here, just to get quick idea. Suppose in this child class, leave about these many examples here now. You don't need all this, just to get the child. I'm not overriding show method. Okay, I'm just declaring some other method like show one, just to cross check. Now I didn't override the show here. I'm creating object for the child here, some equal to PDF, okay, with some parameter, some ABC, just for testing. Then p dot show here. Now by default, what is this? This show method is inherited to child, isn't it? And this abstract method is inherited as abstract method to child as well. Now I'm calling show here as well as 1 minute. Show one, right? Yeah. First I'll call show one, then I'll call. I'm calling both now. Let us run this. But still, if you see, I didn't override this abstract method. Let's run it and see what happens. I got an error here. What is that error? It is saying subclass must implement abstract. Can you see this? And this statement you can just you can write this as per your convenience. Okay, but it should be meaningful. This error statement. Okay, in this object, not implemented error object, you should provide it with some meaningful statement. Okay, but it's not like it should be the same. This is not some built-in string here. This is written by me only. Okay? So that is one thing. Got it right? So if you see, if subclass don't override, you get an error. Got this right? It's clearly saying that here. Suppose if I declare same method in the subclass as well as abstract only. Okay. If I declare this as abstract in subclass also. I don't want to implement it, but just I want that method to be there. Okay. Now let us see. And now you cannot call abstract method. It doesn't have a body. Don't call it. Don't call it. So one thing. Let's run this now. Do you get any error? Because it's an abstract, there is nothing to do with abstract. Now let me run this program. Nothing is coming for us. Because this show one will might be called here. You see here. If you pass it to some print statement, this time you might get something here. You got it right. Show PDF contents. Okay, you get that exception only when you call the show method because it is an abstract. You cannot call abstract method without implementing. Okay, got it right. So that's the simple idea here. Of course, there's a lot of difference between the way how we implement abstract methods or classes in other languages to Python. Got it right. Even now, if you go to other languages, this class has abstract method and this becomes abstract class. You can't create objects for abstract classes in other languages. But here it's not like that. I created object and I am able to call show on as well. So there are certain fundamental differences here between Python to other languages. But still something is there, you have to learn it in the language style, in that language style. So this is how you define abstract methods and abstract. They say that this is an abstract because it has abstract. Got it right there. Even you can declare normal methods as well. You get my point? This is the idea about what's idea about the abstract classes overriding abstract. Got it right? And even what is the point here? You can create a object for abstract classes. Means for a class which has abstract methods here. Usually this is not possible in other languages. You can't do it. And that is how Python is. We have to use it in the Python way only. We cannot go in Java way or Scala way. Got it right? So we're done with this abstraction thing. Hope you got clarity there. What is an abstraction here? We are hiding the implementation, just exposing what's it? Exposing method signatures. And that is nothing but what is that? An abstraction. Maybe if you want, you can add a point here. Abstraction is nothing but is hiding the implementation, not data, and exposing method signatures. Technically, even they have definition wise providing essential information, hiding background details. That is the technical definition. What is that? Providing essential information, hiding background details. This is technical definition. And other definition is more meaningful definition is this one. You want to know exactly what is abstraction means. Usually we implement that with abstract classes and methods. And what do we do with there means this is what we do there. What it said? All of you are good now. So okay, today we'll stop here. We have done this. The other things are same examples. I don't think again you can what is that? A similar example. That's all. Then we can move to the next topic is setters and getters. And then after that, a quick example on encapsulation, because we didn't still discuss that. And all this, tomorrow we can close all this, most of the stuff in our Python. And then we will switch to the regular expressions. If regular expressions is also done, then the next topic will be exception handling. Okay, probably 1 or 2 weeks, 2 weeks more for this session. So, got it right, sir? Multi-threading is one more topic there. That is there. This doesn't take much time. Maybe one week, one weekday. And then database connectivity. All this. Probably I'm thinking one or 2 more weeks is enough to finish all this. Okay. So that will complete the almost all the whole core Python and advanced Python. Analytical Python, we will make it as workshops. We'll plan workshops from next onwards on weekends. Probably we plan workshops as per the schedule which we have there. Okay, the sessions keep going, sir. We are not going to stop this. This knowledge transition or knowledge acquisition, whatever we call it as, this keeps continuing. This is not going to stop, and this will be free. I don't think I am going to plan any paid sessions in the near future, at least for next 1 or 2 years. After that, I don't know. Okay. So that's the point, sir, about this object-oriented programming principles, the polymorphism and abstraction, all that stuff. Okay, we'll meet tomorrow. Any questions, sir? All of you are good so far? Okay, thank you. Thank you. Okay, sir. Please share this with your friends. If possible, please ask your friends to subscribe and learn the concepts that might be helpful to them. Happy weekend. See you.